Here we have a challenge question. This is not the sort of question you might expect in Math 1229, but we include it to try and push your limits and test your understanding of what's going on with vectors. Prove that for any vector v, 0 scalar multiplied by v gives us the 0 vector. Now, so far, we've only worked with vectors in R2 and R3. We can take a look here. Let's just work in R2. So if we're working in R2, our vector v has just two components, which we typically call v1 and v2. Now what happens when you scalar multiply? Well, when you scalar multiply, in this case by 0, each of the components gets multiplied by 0. But of course 0 times v1 doesn't matter what v1 is, it'll still be 0. So we get two components, both of them being 0, and that of course is the 0 vector by definition. A similar sort of thing happens in R3. Our vector v would start with 3 components, and it doesn't matter what 3 components they are. This should work with any vector v, so we don't need to specify v1, v2, v3. We still scalar multiply, and every component gets multiplied by 0. And we know what happens when you multiply numbers by 0. They become 0 themselves. So 0 times v1 is 0, 0 times v2 is 0, 0 times v3 is 0. And a vector with all zeros is the 0 vector. So there, it did not matter what vector v was. That's why we left our components as v1, v2, rather than specifying them as 3 and negative 4. It doesn't work if we're just showing it with a single vector that we've picked out of thin air. We're showing it works regardless of what vector. So with our v1 and v2 there, you can let v1 and v2 be anything. You'll still get the 0 vector here.